One landscape supply family. New company, same great people. Go to birdcolandscape.com.
Do not, my fine young chap.
And how will you be paying, sir?
With gold bars, of course.
With gas prices these days, you'll feel like you'll need lots of gold bars. Red Deer Toyota wants you to save during Red Tag Days. Get 6.7 liters per 100 kilometer average fuel economy on the Highlander Hybrid LE. Now $45.5, or lease it for $132 a week. 4.3 liters per 100 kilometer average fuel economy on the Prius Prime. Now only $38,957.
Good morning, everybody. Wave if you can hear me. Perfect. So, well done on your measurement exam, everybody. We had a class average of 71%. We had 3 people that got 100% on the exam. So that is spectacular. And it's time to start, of course, a brand new unit. I am wondering, and you can let me know in the chat box, if you feel it's worthwhile going through yesterday's exam with the answer key. So if you feel strongly like, yes, I definitely want to see some of those questions that I couldn't figure out, and you have a paper copy at home where you can compare your work, please let me know in the chat that you would like to go through that exam. Otherwise, I won't take your time with it. So guys, here's a great cause and a little bit of a contest. It is about Orange Shirt Day. And I know it's pretty hard to read on here, so I'm not going to get into too much detail, but I'll let you know that the same information is on the school webpage. Oh, let's see here. Ugh, man, I got everything tangled up this morning. So maybe just some of the kind of key things for you, just in case it sparks an interest. It is a contest to create a design to honor residential school survivors. Please include your name, age, contact information. The winning design will be printed on orange shirts for the awareness campaign, and shirts will be sold at Red Deer. Just Red Deer Native Friendship Society. I think those are the ones that are sold online, and like lots of schools will buy them, teachers and students. So a shirt that would be available to a lot of people around Red Deer. Now, deadlines. Submit your design by June 11th. The winner will be announced on Indigenous Peoples Day, which is June 21st. And it does say where to email your submissions to. So maybe this is something you are passionate about, remembering and recognizing people who were in the residential schools, so residential school survivors, or maybe you're just an artist looking for an outlet. So guys, if you wanted to see more details there, it is right on the school webpage right now as well. Or I can always send you a copy of this. Drop me a note in the text or in my email. Okay, let's start with a look at our outline here, you guys. I want to make sure that you have the right booklet ready to go. So this would normally be Unit 4. For us, it's actually Unit 5. So if you want to make note of that, you could do that. So we are starting Unit 5, Relations and Functions. This is the unit where we are getting into graphing. A couple of changes because we are online. What did we think here? So this quiz number 1 is not going to happen right here. Quiz number 1 is actually going to happen in here. So we're going to have a quiz on lesson 1. Lesson 1 is a pretty long one. It will take us more than one day, regardless of what it says up on our outline, that one day will not be enough. Oh, hang on here, guys. I just realized I don't have the current one up. Let me just see if I have the newest version. One momento. Oh, there we go. That's the one that you guys have. Okay, so we said it's actually Unit 5 for us. And we said lesson 1 is going to carry over for a couple days. So we're starting on Wednesday. Going to be one of those days. So we're starting on Wednesday, but going into Thursday. And our first quiz is just on lesson 1. So, you know what? It will be, we'll see how our timing goes. I'm not sure if we will do that quiz tomorrow or if we will do it on Friday. But quiz number 1 is on lesson 1, and this quiz number 1 will be gone. And then I guess just a reminder of all the little check for understandings that pop up really with no warning. And remember, they're just based on homework assignments, so just make sure you're always getting that homework done. All right, so the topic, the unit is called Relations and Functions. And today we're looking at properties of functions. So let's get to lesson 1, everybody. All right, so a little bit of reading for us to start off with here. It says, a relation associates the elements of one set to the elements of another set. Something probably that you've done more in science than you have in math up to this point. So you know how you might, in your labs, you're collecting data and you're showing, I don't know, that temperature and time have a relationship. And then you take that relationship and you put it onto a graph. That's the kind of relationship or relation that we are talking about. We can show a relation as a set of ordered pairs in a table or in an arrow or mapping diagram. We will now extend the definition of a relation to linear relations. Now, I don't know if you would have done this, but back in grade 9, when linear relations were first introduced, they used things like fruits and colors. So you would have in one column, you'd have a bunch of different fruits. and column 2 would be their colors. Or you'd have, your first coordinate was the dog, the second coordinate was the height, and it was kind of as an introduction. And now we will be getting rid of the fruits and the dogs, and we will be working with numbers only. A linear relation is a relationship between two quantities where one quantity depends on another. So my heart rate this morning as I'm riding my bike to work, how high my heart rate was depended on how steep the hill was. So we've got an independent, which was how steep the hill was, because that was just going to be its steepness no matter what. So independent variable. And then the dependent one was my heart rate. My heart rate depended on how steep the hill was. For example, when comparing a quantity such as wage to the quantity such as hours worked, the total wage depends on the number of hours worked. Since wage depends on hours worked, we refer to wage as the dependent variable and hours worked as the independent variable. When graphing, the dependent variable goes on the y-axis and the independent variable goes on the x-axis. This will be one that we definitely come back to when you are setting up graphs, or even you'll just be asked the question, where do you put the independent variable? You'll want to maybe highlight this so that you know where to find it in your notes. All right, so we're going to start looking at some relations in a lot of different ways. The first way here is as ordered pairs. So guys, what I want you to remember is that ordered pairs always have the x-coordinate first and the y-coordinate second. So if we relate it back to what I just put in the box, remember that the independent always goes on the x-axis. So the first coordinate will be our independent variable. And our second coordinate, the y-coordinate, will be the dependent. Okay, so right now we're looking at these ordered pairs. We don't know what they represent, but I can see a pattern in them. In fact, if you look at each one of these, let's start with this one at the end. The y is 10 times bigger than the x. Happens again here. The y is 10 times bigger than the x. Here, here, and even here. So even though we don't know what this represents, I could, from what I see there, I could actually turn it into an equation. Say that y equals 10x. Right now, we're seeing the exact same data. So first of all, we saw the data as ordered pairs, and this is what that same data would look like in a table of values. Now, I want you to notice, normally our table of values, the first column will always be the x-coordinate. Second column is always your y-coordinate. And I want you to notice they didn't actually use x's and y's. They used h and w. Now I think it pops up a little bit later on. Or maybe not. But if we look back to this one where it's talking about your wage is related to your hours worked, that might be where the H and the W is coming from. So maybe the H is the hours worked, And W is maybe your wage. So I think it's kind of a carry on from that example. And then we don't see this one as often, an arrow, or sometimes called a mapping diagram. The first oval is always your X's or your independent variable. And then the arrows show the dependent variable or the Y coordinate that it would be related to. Really, if you look at these three methods, the ordered pairs, values in a table, and values in arrow diagrams, they're really all pretty much showing the same thing, just using a different method. Now it says, can you think of any other mathematical ways we can represent this relation? Now I kind of blew it already, me and my big mouth, because up here I said we could use an equation. Now, if I was to use the variables that they used in their table, it would be W equals 10H. Now it starts to have some meaning. So if you wanted to calculate your wage, you would take 10 times your hours of work. So you should probably quit your job, because that's not even minimum wage, is it? Okay, so equation is one way, and then there's one that's the most obvious way. When I introduced the unit, I said this unit is all about, did anybody catch it? What's one other way that we could show this data? What if we just wanted to have a picture of it? What do we call a picture when you're putting a bunch of data points on a picture? I know you guys know this. Don't leave me hanging. Janae, what do you say?
Is it a graph?
It is a graph. Thank you. I was getting uncomfortably silent there for a while. And remember when we set up our graphs, it's always X on the horizontal and Y on the vertical. And so from what we've already been talking about, X is the independent variable. And Y is the dependent variable. Now the little axes that I set up here are really only going to work if all the X values and all the Y values are positive. So be prepared to work with graphs that have all four quadrants. That will happen, but for right now, just because of where I've labeled it, it's okay to have that as our diagram. Okay, so let's talk about a few words that will be new. So what we've looked at so far hopefully doesn't feel too new. Maybe it was just a little bit of a refresher. But what will be new for us in lesson 1 is we're going to be working with domain, range, and function. So we'll be looking at relations. And remember that relations can come in any of these ways. So we're going to look at a relation that's given to us as a list of ordered pairs. Or a table of values or an arrow diagram or an equation or a graph. So we'll look at a relation given with one of those methods, and we will have to decide what is the domain, what is the range, and we'll have to decide, is it a function or is it not a function? So let's start with function. Here's our definition. A function is a special type of relation where each element in the domain is associated with exactly one element of the range. Now, we don't really know what domain and range are at this point. So in our own words at this point right here, we'd probably say all of the x coordinates are different. Consider the following relation. It shows a relationship between gross pay and hours worked. Now remember that the first column is always the x coordinate. So if we were going to put this on a graph, that first column is your x coordinate. The second column is always your y coordinate. So let's take a look at all of the x coordinates in this relation. We've got 1, 2, 3, 4, 5. All of the x coordinates are different. So this is a function. Okay, and then we've been talking about independent variable and dependent variable. Here's maybe a better demonstration. So hours worked would be the independent variable, since the number of hours worked does not depend on the pay. We say that H is the independent variable. And maybe you just want to put beside it, just as a reminder, when it comes to graphing, that is always the x coordinate. It always goes on the x-axis. Gross pay is the dependent variable. Since the pay depends on the number of hours worked, we say that P is the dependent variable, and probably just a little reminder that that would go on the y-axis, and that would be the y coordinates. All right, so the question here, which of the following are functions? Now let's just kind of glance ahead at what's coming up. The first couple here, we're looking at relations that are given to us in graph form. Number 3, this is a relation that's given to us with ordered pairs. Number 4, that's a relation that's given to us with a mapping diagram or an arrow diagram. Oh, there's a few more coming up. Here we're looking at more that are given as graphs. So remember that relations can be shown in a lot of different ways. Now what we're doing, if I'm going to look back here, if all of the x coordinates are different, that means it is a function. So that's what we have to look at. Now I would say the easiest one to look at is to figure out here is number 3. So let's do that one first. We're looking at every x coordinate. Oh, so I'm looking at every x coordinate, and I see there are some x coordinates that are the same. So since some x coordinates are the same, this is not a function. So I'm gonna say it's probably the easiest to figure out when the coordinates are actually listed for you. So we look at all of the x coordinates, and if any of them are the same, it is not a function. Now, number 4, this mapping diagram, is another way of giving ordered pairs, but it is not as clear. Things to remember, the first group of numbers here is always your x. The second one is always y. And you know what, guys, if you ever have a hard time and you mix those up, it happens to be alphabetical order. X is always first, y is always second, just like in the alphabet. I'm going to convert this arrow diagram into a list of ordered pairs. And that way you'll understand what this arrow diagram or this mapping diagram is doing. It's saying that there's a 3 for the x. We'll go with 2 for the y. It's saying 5, we'll go with the 1. 7 will go with the 2. And 7 also goes with the 1. So when we look at all of the x coordinates, again, I see, yeah, we've got some x coordinates that are the same. So this is not a function. Okay, so remember, some relations are functions and some relations are not functions based on their x coordinates. Let's look at the graphs. Now, we won't do this every single time, you guys, but I'm going to list the ordered pairs here again, just so we can actually see the x coordinates. So this first point, remember again, this is the x axis, this is the y. So this first point is the point 1, 1. The next point up is the point 2, 2. Then we have the point 3, 3. And the point 4, 4. So here I'm looking at the first coordinate for each one. I'm looking at the x coordinates. And they are all different. Since the x coordinates are all different, this is a function. Now, what I said there was, you won't have to, yeah, Janae, you go ahead. We won't always have to list all the coordinates, because we're going to see on number 2 that it's very obvious when you have 2 points with the same x coordinate. So I'm just going to label a couple points this time. Let's take a look at this point that I put in red and this point. The bottom one lines up with the 3 on the x axis, and it lines up with the 1 on the y, so it's 3, 1. Let's look at the red, the top one on the red. It lines up with 3 on the x, and it lines up with 2 on the y. So those 2 points have the same x coordinate because they line up within the same spot on the x-axis. So you know what? Just that right there, just knowing that 2 points have 3, they have the same x coordinate. That's enough to say this is not a function. But I want you to see the pattern here. There's all of these points right here would have an x coordinate of 2. And all of these points right here would have an x coordinate of 1. So when you have points lining up vertically, one above the other, you know right away, oh, those have the same x coordinate. This is not a function. Uh-oh, there goes all my points. Whoops. Let me fix it up here. So this one is not a function. So guys, any questions so far on that idea of figuring out, is it a function or is it not a function? All right, now eventually we get into graphs like this, where they don't actually have specific points labeled on them. This graph right here, well, all of these graphs, they have so many points have been plotted that every single point, they're all touching every point on this path is part of the relation. So when you see a graph, oops, there we go again. When you see a graph that that is a line, think of it as an infinite number of points all being connected. And your job is to figure out, do any of those points have the same x coordinate? Well, we have a really easy way of figuring it out, and that's the vertical line test. So if any vertical line cuts through the graph more than once, the relation is not a function. So in our demonstration here, you guys, we're looking at this kind of oval shape. That's our graph. And you've got that dotted vertical line. When that vertical line is drawn, it touches the graph here and here. So if it touches in 2 places, it is not a function. Those 2 blue points that I have on there, they would have the same x coordinate, wouldn't they? Whatever this is, let's put a few notches on our x-axis here. My board's not very lined up. So we'll say that's -1, this is -2. Both of those blue points would be x coordinates of -2. So we don't have to go in there and like find all the x coordinates. We just have to see, are there 2 points on the graph that line up vertically? So over here, the graph that we're looking at is right here. It's just a line. The dotted line is the vertical line. So we draw this vertical line, or maybe we just hold our ruler vertically, and we see it crosses the line once. So this one is a function. All right, so I want you guys to go ahead and try these ones out. I'll give you a demonstration. Let's we'll do the first one together. So guys, what I do is I take a straight edge and I hold it vertically. Now I'll draw just so that you can see what I'm talking about. So I've got this kind of diagonal line for this one, and I'm going to try to draw a vertical line that would actually touch it twice. But you know what? I could draw the vertical line here. It only touches once. Draw it here. Only touches once. I could draw it here. Only touches once. No matter where I draw the vertical line, it would only ever touch the graph once. So this is a function. And guys, you don't have to draw that many lines, but I'm just trying to demonstrate that your job is to try to make it touch more than once, if possible. But it's impossible here, so this one is a function. Because my vertical line only crosses the graph once. So guys, I want you to go ahead and do the next 5. I'll be asking for answers. It's really a yes or no answer, so have it ready. All right, Paul, I'm going to get you to do the second graph. So all you have to tell me is yes or no, is it a function?
Yes.
Yes, because no matter where I try, doesn't matter, I could try drawing that vertical line in any single position, it's only ever going to cross once. So it is a function. All right, let's take a look at this one. Kyler, what do you think for this one? Yes or no? Is it a function?
No. Oh,
No.
the third or the fourth one?
The one with the blue star here. Is it possible to draw a vertical line that touches the graph twice? See how it touches the graph right here, and then it touches the graph again here? So if it is possible to draw a vertical line that touches the graph more than once, then it is not a function. Guys, any questions there? All right, Kale, what do you think about the one coming up here with the green star?
Not a function.
Not a function. And it's kind of a weird one because if you think about it, I'm going to draw my vertical line here. Man, that vertical line is touching the graph in so many places. In fact, every point that's on that graph would have the same x-coordinate, wouldn't it? So this is definitely not a function. All right, and the next one, the one in the middle here. Francis, what did you say, yes or no?
Yes.
Perfect, because no matter what, I could try and try and try, but no matter where I draw my vertical line, it will only ever touch once. So yes, a function. Now the last one. I think we might be up for a debate on this one, to be honest. Seamus, what do you think? Did you say yes or no?
No.
So you said no. Now, can I find anybody who says yes? Who's gonna maybe get in a little debate as to why it's yes or why it's no? And Seamus, tell me, how did you figure out no? So I'm gonna go with Seamus. I think he's got the right answer here. I'm gonna say not a function. Seamus, where did you draw your line? Just describe to me, if you could, where you drew your vertical line, where it touched the graph more than once. Because I know if I draw my vertical line, if I draw a vertical line here, definitely only touches once. If I draw it here, it definitely only touches once. But the thing is, you have to try to make it touch more than once. So if I do a vertical line in here, I'm gonna have to just move it a little bit. If I do it in here, it's almost like there's a flat part where it's touching in a few spots. So I would just say move, we don't want that one, we don't want that one. But the line that I left here, the vertical line test, that's the line that shows it is not a function. All right, guys, so we are going to do a really quick little no, not yet. We're going to talk domain and range, then we'll do a quick assignment. So that's it for function. And that's really all it ever is. It's a yes or no question. Is it a function or is it not a function? Okay, the other two concepts, domain and range. Domain is the set of all x coordinates of the ordered pairs of a relation. And the range is the set of all the y coordinates of the ordered pairs of a relation. So it says, therefore, using the last example that related wage to hours worked, we can write the following. So guys, the points that we're looking at here, all the way back to these ones right here. You know what, I'm just going to take a little snapshot here. Okay, so this is our list of ordered pairs right here. And so for that relation, you can see we've split up the domain. All we have to do to get the domain is we just make a list of all of the x coordinates. Pull all those x coordinates out, and that is your domain. And our range here is a list of all of the y coordinates. Just put all the y coordinates out, put them into a list, and that is your range. The elements of the domain are often referred to as input, and the elements of the range are often referred to as output. And that's because when we start dealing with equations, I'm just going to make a random equation for you here. Our equations are usually written in the form of y equals. So if we had, let's say, y equals 2x plus 7, well, x is the input number, and y is the output number. Now, there's something here, too, that has maybe gone unnoticed, but you may have seen all these curly brackets. When we make a list of ordered pairs, we have these curly brackets. When we make a list with a domain, we always have these curly brackets. And it's not just because we like to be fancy, but it's because that is called set builder notation. And it's about using the proper notation in math. So here it says, using the correct notation, state the domain and range for each of the following relations. All right, so our first relation here is just a list of ordered pairs. That's probably the easiest type to work with. Now, when I list my domain, I need curly brackets. And not just proper notation, but also there's a proper order. So we always list them from smallest to biggest. So always from smallest to biggest. And don't list any repeats, or we'll say repeaters. Okay, so I'm going to start on this first one. My domain is just a list of the x coordinates from smallest to biggest. 0, 1, 3, 7. Okay, and then the range. Range is just a list of all of our y coordinates from smallest to biggest. Oh, it's pretty easy. They were already in that order. Maybe not the best example here, but do remember, guys, to make sure when you are doing your work, you list them from smallest to biggest. Now our next one is a mapping diagram. So our domain is going to be the x coordinates, 1, 3, 5. So again, I must have been half asleep making up this example, not making us work very hard. Remember that your first list is x, your second list is y. So the range, curly brackets, 2, 4, 6, 8 from smallest to biggest. And guys, we're ready for today's practice. And remember, in your practice, they're not always going to be like this. They won't always be given to you from smallest to biggest, but you make sure that you list them from smallest to biggest. So guys, go into your worksheet booklet. And lesson 1 worksheet has a page 1, a page 2, and a page 3. And your job is to do all of those 3 pages. Any questions before we get to work? Grade 10s, I'm going to interrupt just for a moment here. A couple announcements for you at the end of class. First, I want to just check my attendance, and I just want to confirm with Hannah, Jet, and Christian. If you guys are here, would you please let me know in the chat box? And you guys, tomorrow we'll be carrying on. We'll finish lesson 1. And then we're going to take a vote to either just do our quiz or will we start into lesson 2. So there'll be a little bit of a vote for us tomorrow. Friday, we're going to bring back the old Flashback Fridays. I want you to try to locate the ones that you've already received. Last time it wasn't Flashback Friday, it was Throwback Thursday. So try to dig those out, see if you can find them. I will post them on Google Classroom as well. And there's not a lot of like print. It's not something you'll have to print off. You can always write the questions down on loose leaf. So that is coming up over the next couple days. Do you guys have any questions before we sign off? All right, remember, stay strong, be kind. Take care of yourselves, guys. See you tomorrow. Emily, how you feeling?
Better now, finally.
Like 100%?
Yeah, I think so.
Oh, good. Thank goodness, hey?
Yeah.
One of my, we're having the whole close contact thing going through our family because my daughter's roommate was positive and my son had been hanging out at her house. And he had a friend that he took over to their house to watch a movie. And now it's like, oh, man. So
yeah,
we got the whole, yeah. We're lucky that he wasn't positive, but his friend that he took along did get positive, and now his whole family's in turmoil. It's like, when is this?
My parents couldn't work for like 2 weeks because of me.
Yeah, it's, you know what? It's just amazing how many people it does affect, hey?
Oh, I know. I'm surprised none of my friends got tested positive.
None of them did?
Nope.
That's good.
Yeah.
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 Yeah. Well, take care.
Are we doing our quiz tomorrow?
We're going to vote. So we'll kind of finish the instructional part tomorrow and get a little practice time, and then we'll vote on it.
Okay. And the flashback, that's Friday?
That's for Friday, yeah.
I don't know why. I thought we didn't have school Friday, but maybe that's next week.
You know what? Next week, we do not have school Friday.
Right.
Well, who knows? That's on the original calendar. I really haven't heard one way or the other, to be honest. But.
All right. Well, thank you.
Take care.
Bye.
Miss Booth.
Yes, Kyler, how are you?
I'm good. How are you?
I'm doing okay. What can I help you with?
So I was relocated from my house and I'm at my auntie's now.
Oh, okay. How's it going there?
It's going pretty good.
Yeah, this was a good move?
Pardon me?
It was a good move for you?
Yeah.
Oh, good.
I thought that, because I know you gave us all of the booklets that we were going to need for online that one day in school.
Yeah.
But I'm pretty sure I somehow managed to forget my other booklets at home. And so today I was just writing all the notes down on a piece of paper.
Oh, man, were you able to keep up? That was a lot of writing.
Yeah, I just copied down all like the notes and stuff. Like I copied down some of the examples, but not all of them.
Mm-hmm.
And I was just, because I know that the booklet is on Google Classroom, right?
Right. So you could, like, I don't know what kind of access you have to paper, printer, or ink. You can print them off from Google Classroom, but you can also pick them up at school here.
Oh yeah, I'm in Morinville, so
Oh, okay. So that is not a possibility, hey?
I know my auntie has a printer here, but we're just not sure how to connect her printer to my computer.
Oh, I see.
So that's
So would you be able to print it? Let's say I emailed it to your auntie so that she had it on her computer. Would she be able to print it for you?
yeah, she probably could, yeah.
So we could do that if you want. If you want to send me her email address, and I can email both booklets to her for printing.
Perfect. Yeah, I'll do that.
Okay.
Okay, thank you.
Oh, you're welcome. Have a great day.
You as well.